right triangles, and in this first section, chapter 3.3, it's about a special type of right triangle, a triangle that we call a 45, 45, 90. So let's just draw a picture over here on the right side of a 45, 45, 90, and let's talk about everything that we know. If this angle is 45 degrees, and this angle is 45 degrees, and this angle is 90 degrees, then together, the sum of all three angles is 180. Because these two angles are 45 degrees, then we say that these two legs are congruent to each other. And the hypotenuse is what we call the longest side of the 45, 45, 90. It's also the side that is opposite the right angle. So today in this lesson, we are going to refer to the legs and the hypotenuse. What we do know is that the hypotenuse, again, is always the longest side. And in a 45, 45, 90, the hypotenuse is always radical 2 times as long as the leg. So if my leg has a value of x, my other leg has a value of x, then my hypotenuse would be whatever x is times radical 2. Right. So let's start with number 2. In number 2, I noticed that both the legs are 7 radical 2. And to find the hypotenuse, we just discussed that the hypotenuse is what the leg is, 7 radical 2 times radical 2. The hypotenuse is always radical 2 times the leg. So when I multiply radical 2 times radical 2, radical 4, and the square root of 4 is 2. Square root of 4 is just 2. So 7 times 2 is equal to 14. So C, in this problem, C is equal to 14. Now in number 4, we're trying to find the measure of the leg. So if we know from the leg to the hypotenuse, we multiply by radical 2, then from the hypotenuse back to the leg, we're going to divide by radical 2. So to find the value of A, I'm going to take my hypotenuse, 12 radical 2, and I'm going to divide by radical 2 instead of multiply. Another way of thinking of it is if we want to go from the hypotenuse, which is a longer side, to the leg, which is a shorter side, we need to make that a smaller value. So the way we do that is by dividing. So what I notice is that I can cancel the radical 2's to 1. So A is equal to 12. Number 6, I need an equation to help me to find x. What I do know is that the measure of all three angles in a triangle equal 180 degrees. And I can find the measure of this first angle, and the way that I can do that is that I notice that together these two angles equal 180 degrees. So to find this missing angle right here, I'm going to take 180 degrees and subtract 132 degrees. And then I'm going to do the same thing for this angle here. 180 degrees minus 112 degrees. So now I can write an equation that can help me to find x. Let's just move these over here. So my equation equation is 48 degrees plus 68 degrees plus 2x plus 4 degrees together has a sum of 180 degrees. So I began by adding my like terms together. 48, 68, and 4 is 120. Therefore, 2x is equal to 60. So x is equal to 30. For part B, I can do the same thing. Together, these two angles must be 180 degrees. So the missing angle is 90 degrees. So I can now say 90 degrees plus 3x plus 2 degrees plus 2x plus 18 degrees equals 180. Let's do number 8. Let's do number 8. We need to calculate the distance between each given pair of points on the coordinate plane and round my answer to the nearest 10. So I'm going to begin with number 8 by drawing a right triangle. To find the distance between these 2 points. And I'm going to call that distance C. So I'm going to use the Pythagorean theorem, which states in a right triangle that a squared plus b squared is equal to c squared. So when I count the number of units, 1, 2, 3, 4, this side is 4. This side is 1, 2, 3, 4, 5, 6, 7. I can say that 4 squared plus 7 squared is equal to c squared. I'm going to move this over here so I can pull up my calculator. In my calculator, I'm going to write the following equation. C is equal to the square root of 4 squared plus 7 squared. So when I want to solve for C, I take the square root of both sides. I take the square root of C squared, I get C. And then all I need to do now is enter all of this into my calculator to find the value of C. So let's take a look at how we do that. So I'm going to begin with second square root. So I have a big square root now, and I'm going to enter in 4 squared plus 7 squared and the distance C is 8.1 rounded to the nearest 10. All right, in number 10, we're going to begin by drawing a diagram of the situation. Nina is picking oranges from the tree in her yard. she rests a 12-foot ladder against the tree at a 45-degree angle. So here's my tree, here's my ladder, and here's my 45-degree angle. So I begin by drawing a right triangle, and I know that the ladder is 12 feet long. She rests a 12-foot ladder, so the number 12 represents the ladder that she leans up against the tree. The question is how far is the top of the ladder to the ground? We're going to call that x. So we're going to use our 45, 45, 90 relationships, and what we remember is the hypotenuse is radical 2 times the leg, and if I know the hypotenuse and I want to find the leg, then I divide by radical 2. So to go from the hypotenuse to the leg, I take the number 12 and divide that by radical 2. And we say that that is approximately 8.5 feet. And again, we're going to begin with a diagram for number 12, which involves a mosaic tile that's in the shape of a 45, 45, 90. And in this tile, the length of the hypotenuse is 13 centimeters. The question is, what is the area of the tile? So in order to find the area of a triangle, I need to use the following formula. 1/2 the base times the height. So when I look over here in this drawing, I notice that I don't know the base, nor do I know the height. However, I can find the base and the height by using the relationship of a 45, 45, 90 from the hypotenuse to the leg. I divide by radical 2. So if my leg is about 9.192388.155, and the other leg is the same distance, so let's take a look here. Both of these sides are about 9.1, then I can substitute for my base and my height being the same value. No, and I should probably round that a little bit better. Let's do 9.2. So to find the area, I can multiply the base times the height and divide by 2. So I already know the base. I'm going to multiply that or square that answer. So when I square 9.192388.155, I square that, I get 84.5, and then I need to take half of that, or I simply can divide by 2. The last page, there are some little some of the postulates and definitions, theorems, and properties that we've learned. So taking a look at number one, what we see is we see a diagram where A is the midpoint of segment DC. Okay, and if that is given to us, that's what we know, then here's the conclusion we can now make. We can now say that the distance from D to A is equal to the distance from C to A. And that is by the definition of a midpoint. So by definition of a midpoint bisects a segment into two equal parts. In number 16, we have segment AB, and I'm just going to extend this segment, is parallel to segment CD. And so when we have parallel lines cut by a transversal, then we have alternate interior angles that are formed. So I can now say that angle A is congruent to angle C. Should number these, move that over. And we can just say alternate interior angles. And I can also draw a transversal this way. And again, I have alternate interior angles. So in addition, I can also say that angle B is congruent